Again, you don't have to be the master of SQL. As you will see, the search processing language resembles both Unix pipe and SQL. And that's why I have this in the prerequisites. But again, if you don't have any of this experience, no problem at all. You can get up and running in no time. Basic understanding of data you're trying to analyze using Splunk. In my mind, this is more important than learning the tool. You could be a security analyst or a software developer trying to use Splunk to troubleshoot your application. You should really know what you're looking for and what it means. Otherwise, those charts and beautiful graphs that you create will be of no use, right? Now, this is something you can develop as you go, but I want to make a point that that's very important to make use of Splunk. This could mean sometimes you have to bring in the expert who knows more about the data and maybe work with them. Here are the course goals. Understand the Splunk platform basics. So this is what we will do during the first segment. I'll give you a background of what Splunk is, what it can do, how you can use it, etc. We will learn SPL. So SPL is going to be the backbone, search processing language. That will be your Swiss Army knife, if you will, to slice and dice your data. And then we will move into reports, dashboards, and alerts. This is where you will actually apply what you learned by learning SPL. We will actually look at many visualization components of Splunk. As you will see, it's very easy to create dashboards in Splunk. Here is a high-level outline of the course. There are totally 6 segments. First segment, we will look at Splunk platform basics. Then we will move on to using SPL. And this is where I'll introduce you to how to form a query and run it. We will also look at the search app that you will use to run your searches. In segment 3, I want to touch on 3 important commands, SPL commands, that you will use over and over. If you were to master just few commands in SPL, focus on these: eval, stats, and chart. Now, time chart is a variant of chart, but if you learn time chart, that's good enough. Segment 4, we will go into creating reports and dashboards. This is where, like I said, you're going to create some value that others can make use of by saving what you did and sharing, right? Reports and dashboards. As we will see, you can even email a PDF of a dashboard on a periodic basis to someone. Segment 5, we will look at alerts. And if you come from IT operations background, maybe from NOC or just a developer who wants to be alerted when something goes wrong, in that segment, we will see how to configure alerts and thresholds and various actions you can take when the alert triggers. Segment 6, we will look at some advanced customizations. We will look at drop-downs in dashboards. You will be able to create an interactive dashboard on top of the Splunk platform. For instance, a user can choose certain values of a variable, and then your dashboard will basically refresh based on what he chose. Almost like a mini web app, if you will. I hope this sounds exciting and interesting. This is a lot of content, a lot of value here. I really believe that it will be useful to you. Okay, a little bit more about me. I am a Splunk certified architect. I have been working solely on Splunk for about, I would say, 6-7 years. I have deployed large-scale Splunk environments, multiple hundreds of terabytes per day. I have experience in systems and network administration. I have also worked as a software developer for a while, but lately I've been focusing on observability and related tools. And I'm also leading teams to develop solutions using Splunk and other platforms as well. All right, so before we dive into the content, I want to take a quick poll. This helps me understand where you are coming from, where the audience base is coming from. What is your role at your organization? So what is your day-to-day work? Here are the options: application support engineer or an SRE, software developer or an architect, a SOC person. Splunk has been increasingly used as a SIM, right? Security incident and events management, SIM platform. Or you are a network operations analyst, or you come from middle management leading a small team, or you come from a senior director or a VP plus, leading an organization. So go ahead and enter your result, your answers there. We'll take a look in just about a minute here. We'll give about 20 more seconds and we'll look at the results. This is always the best part for me to understand more about you guys. Yeah, MK says none of the options fit. I think maybe a data scientist I would have to add, I guess. One of them brought that up. Okay, we'll move on. All right. Okay, so not surprisingly, there is an equal distribution between application, the SRE org, and software development org, and the security operations analyst. Some of you are from middle management. That's great. NOC, as we know, as I know, has been kind of going down. The operations have been shifting more towards SRE and actually application development org themselves. So that's interesting, and I see this trend every time when I give this training. It's a little bit about the software development org. You can absolutely use Splunk to do wonders, not only to know what's going on within your application, but to set up production monitoring and to help the support team. In most cases, you are the support team, right? You guys are called when you come into a war room, then, here's our development team. Now everything will be solved. So it's important that you know how to use the platform and then develop your own monitoring that helps you to solve problems. Same goes with application support engineers. You guys are the first line of defense in most cases. So setting up enough knowledge, enough intelligence on your operational data is crucial. It can save tons and tons of time and agony if you get this right. If you develop the right operational intelligence using the Splunk platform. All right. Let's move on here. We will cover the basics. Just a little bit of a warning here. This could be a little bit theory, but it's important that you grasp that so you know what the platform actually does and how it works. The remainder of the segments are all going to be demo driven. Even in segment 1, towards the end, we will actually open up Splunk interface. We will upload tutorial data that we'll be using to do all the demos. So this is not completely theory. There is a little bit of demo at the end. But after this segment, it's going to be all demo driven. Okay. So in order to know what Splunk does, you need to know about machine data. It's in a crudest form, it's the digital exhaust produced by any device in the network, right? Typically, we think about logs and traces and metrics and the like. Not long ago, you would just have one or two servers, one web server, one app server, one database server, the 3-tier architecture. It was so easy to just log on to those servers and see what's going on. But those times are gone. Right now, in the container-based world, you don't even know where your code is actually running. So it's important that you not only collect the machine data that comes out of it, and then you organize it and make it accessible in a way that you can make use of it. So in a way, there are 3 broad categories of machine data: events, application logs, this is what most of you are familiar with, and then the metrics, these are numerical data. The industry literature has some variants to it. They call it logs, metrics, and traces, the 3 pillars of observability. Practically, this is how I see it in terms of the categories of the machine data. Machine data is everywhere, right? I have listed only some of the components that we deal with on a day-to-day basis in IT. authentication, audit, middleware, operating system, network devices, databases, messaging systems, applications, mobile devices, call record details, LDAP, tons, Kubernetes container, platform logs, etc. Now, inherently, like I touched on before, there is a huge engineering problem on how to make use of this data, mainly because they are super fast, right? It can, in the biggest environments I have worked with, it can reach about 1 gigabytes of machine data per second. We're talking 1 gigabytes of machine data. Sometimes they're not structured, so a system needs to parse them to organize them, right, to index them. So that's a big engineering task. You really need a highly scalable, distributed system to process all that, and that's where Splunk comes in. They are huge, multiple terabytes per day. So the biggest environment I have worked with, we had few Splunk clusters, but overall it's close to like 170 terabytes of data per day, and that's lots and lots of data. And if you think about retaining, these are, I only talked about per day, right? If you have to retain the data, let's say for 90 days, which I recommend for any use case, you're talking like a petabyte of data or more. So there's a lot of data, and they are distributed. Like I mentioned, this is where the challenge with the collection comes from, and we will see how Splunk solves all these problems. Splunk to rescue. You can ingest data from anywhere, and I totally mean that. As long as there is network connectivity to the Splunk platform backend, meaning indexers, and we will see some of the core components of Splunk, as long as there is network connectivity, it can use any protocol, HTTP, TCP, or agent-based. Splunk can ingest data into Splunk, into the indexers. So that's one of the core strengths of Splunk. It can index unstructured machine data at scale. Now, at scale is important. Like I said, it's a completely distributed parallel computing system. It can scale really, really high. Now, some of you may challenge that when it really gets to, security data are like multiple gigabytes per second. Yes, I have seen even Splunk struggle. That's where, someone who can really tune the platform need to come into play and then help you guys out. It could be maybe splitting the cluster and then organizing it that way. But for the most use cases, Splunk is awesome in ingesting data. For the most practical purposes, we are not going to be dealing with multiple, petabyte scale per day. Powerful query language, and this is what you'll be learning a lot today about the SPL, right? Like I said, master SPL and you master Splunk. You will see that even some of the reports and dashboards, ultimately they are powered by SPL. Versatile visualization, we'll see how you can you don't even have to draw anything. Just use commands to create visualization automatically. As a matter of fact, whenever you run a statistical command, Splunk automatically creates a visualization for you and makes it available in a different tab. So we will see how that works. Extremely extensible, and this is important as well. You can build your own app, so to speak, on top of Splunk platform. We won't be covering that. That's a little bit advanced. You have to follow a certain framework to create an app. And in most cases, you don't need to create an app. There is always someone has already created an app for you, and then it's available. And also, while it's extensible, for most use cases, you may not need to use any customized app. By default, the vanilla Splunk installation will give you more than what you need. AI ops and machine learning, and some of you may be interested in this. Splunk provides machine learning toolkit that you can run on top of Splunk platform. Because naturally, you can see, the Splunk platform ingests terabytes and terabytes of data. What are you going to do with that? My personal opinion is it's such a waste if you don't use it for, of course, monitoring and troubleshooting is one thing, but there's a lot of intelligence to be reaped out of that, terabytes and terabytes of data. So I always encourage, if someone comes up with, can I use machine learning toolkit to run on top of Splunk to make use of this data? Absolutely. That's a little bit advanced concept we won't be covering in this course also. At a high level, this you can think of this as a 100,000 foot view. Left side, you have the machine data sources sent to Splunk platform, and you connect the Splunk platform to search, report, and analyze. Here are the core components. Indexer is a Splunk process. It's a Splunk D. It is a C++ binary. It's most of the underlying core component of indexing is done in C++. There's a lot of Python that got added lately. So you can think of this as maybe like 10 to 20% Python and 80% C++. In Windows, it runs as a service. And in Unix world, you will see it as a process, Splunk D, right? This indexer process is the one that receives, parses, and stores the machine data in files. It also responds to the search request. So it's both reading and writing is done by this binary. Search head is the same Splunk D binary, but you configure it to be a search head. What it does is it doesn't index data, but search head is the one that you connect to perform your searches. It's a web interface for the users. It dispatches the searches you submit to the backend indexers. Okay, so most of this course will be just logging onto search head. As a matter of fact, I'll be doing this in my local Mac. So both search head and indexer are in the same process. Universal forwarder is the one probably you are close with. This is the agent, so to speak, that runs on your application servers or containers or anywhere where you need to collect data from. It's an extremely fast and performant process. One of the questions I get asked all the time is, hey, you're going to be installing Splunk Universal Forwarder in my production box. Is it going to take down my server, right? And, fair question. If you're an application owner or a developer, you're worried about it, you will ask that because you don't want to just keep on installing hundreds of agents in your server. I have never seen Splunk Universal Forwarder causing issues. Now, with that said, though, Universal Forwarder's job is to collect logs. Let's say your application is writing millions of small log files. Usually, there is more problem with collecting data from millions of logs than one log that is like a terabyte of size, because you just need to tail and then grab the data. Whereas if you have millions of files, then underlying the way you open them and manage them, close them is so much more overhead. So at that time, I have seen Universal Forwarder taking up a lot of CPU and memory. But again, that's because of what you're asking it to do. For most practical purposes, it is highly performant and fast. And sometimes people ask, how long does it take for the data to go from Universal Forwarder to indexer, right, end to end? Because you need to know, you don't want your data to show up after 2 hours. What's the use, right? Again, in most cases, it is less than a minute. I'm saying minute actually as a higher watermark here. In most cases, it is seconds. But obviously, it depends on how it's architected. You may have to, the data may have to travel through some network, firewalls, or whatnot. So there is always that overhead. But in most cases, less than a minute. All right. Just a few more slides, and we'll dive into demo here. Okay, so the data flow. How does the data flow from end to end? Now, your application on the left, right logs, and then the Splunk Universal Forwarder reads it. Splunk Universal Forwarder is not the only way to ingest data. So in I think upcoming slide, I'll show you the other ways of collecting data. But this is the most common way to collect data. The Universal Forwarder, it does very little bit of processing. So but it doesn't like parse data or anything, but very little processing. And then it sends it to the indexers. Indexer is the one that parses the data and then stores the data in files. And then we have the search head. Again, it's a Splunk process that reads from the indexer. The user, like me and you, will be always connecting to the search head to run our searches. The Splunk licensing option, you probably are not directly involved with this. Your organization could be, but I'll go through this. And the licensing option has recently changed. But what you see here, for the most part, has not changed. You can have an enterprise license. The enterprise license goes by the amount of data that you ingest per day. Recently, Splunk introduced compute-based license as well. You can have a free license, and this is the best part, right? You can download Splunk as a trial version. That will be good for 60 days, all the features available for you, alerting, dashboarding, everything. After 60 days, you have the option to convert that to free license. Free license is for you to keep for life. And the only thing you cannot do that is configure security. Well, actually, two things you cannot do is configure security, and you cannot create scheduled jobs, which is a requirement for alerts. So you won't be able to create alert. And there is also an IoT license. Forward license is actually not required going forward. You don't have to worry about that. And then the dev test license. So I want to make a point here. If your organization is Splunk customer, you can get a developer license that is good for 6 months. You can ingest up to 50 gigabytes per day of data. With a trial license, you can only ingest up to 500 megabytes of data per day. 50 gig is a lot, and 6 months is awesome. So you will have to go through the sales organization of Splunk. So you may want to contact your leadership and then see how that works. But if you're a Splunk customer, you can get a dev license, and you can put it in your own Mac or PC and then play with it if you want. Okay, I'll just breeze through this slide here. Input is where universal forwarder and many ways of collection. In the next slide, we'll see what are the different data types, and then how we can ingest them. Parsing, you can do it in a component called a heavy forwarder as well. We won't go into the details of that. And then the indexing at the end. Data input types, yeah, like I said, it can ingest data from anywhere and any type of data. The only requirement is, for obvious reasons, it has to be a text, ASCII based. You're talking indexing, machine data. You throw binary data at Splunk, it won't be able to index. And that's obvious. And you'll see that Splunk indexes every term from your machine data. It's not very different than the typical search engines, such as Google or Yahoo, where every term gets indexed, so that when you search for something, the searching system can bring back the results quickly. So Splunk works pretty much the same way. The technical term for that is actually an inverted index under the cover. If you Google for some, Splunk how indexing works, and you will see it's pretty interesting on how that actually indexes. Major categories are files, network data, syslog, and if you come from a network world, a syslog, even from security world, you will collect data using syslog, the good old syslog daemon that's still being used and very powerful in many of the network devices, right? You can ingest data, syslog into Splunk. HTTP event collector. Now, this is for if you come from development world, this could be a very useful thing for you. You don't have to install universal forwarder in your server where your application is running. By adding a little bit of piece of code and some minor changes, you do have to make code changes, by the way. You can send data directly from your code to Splunk via HTTP. You will be posting. If you come from the Java world, you are probably using log4j or logback, and it's essentially adding an HTTP appender to your log4j or logback and provide certain configuration information for Splunk HTTP event collector, and there you go. Okay, so whatever you log using log4j or logback will get to Splunk. You can also send data using scripted output, meaning you can write any script using any language. You essentially configure your universal forwarder to run that script, capture the output, and then send it to Splunk. DB Connect is another popular one, guys. So this is where you connect to your Oracle or SQL Server database, run a query, and then index in Splunk the results of that query. And you might be wondering, why would why would someone actually ingest data from database into Splunk? There are many reasons. Sometimes it depends on the application team and the application. You may want some metadata from your Oracle database in Splunk, things like that. Okay, and here's a popular question. Where does the data actually get stored in Splunk, right? I keep saying indexes,